In this tutorial, I will explain different settings and definitions of floating apertures and how the settings and behaviors of lens edges can be defined. As you might already know, the floating apertures can be activated by unlocking here this lock icon next to the aperture radius field. So when this lock icon is unlocked, we have a floating aperture, and when we click on this icon and we set it to locked, we have a fixed aperture. For the fixed aperture, the value applies that we enter directly here into the aperture radius field. For our case, we want a floating aperture, and for that case, we just click on it in order to unlock this icon. To define and change the settings of the aperture radius and the lens edge behavior, we will go to our lens and click on this plus icon that we can see there. Here in this lens settings editor, we have different options. The first option is the aperture margin. When we enter, for example, here 2 millimeters and click on update, we can see that here for the first surface, the aperture has increased in the size. So in that case, those 2 millimeters have been added here to our aperture. Important to know is that these lens settings as the aperture margin are only taken into account when our floating aperture is activated. So make sure that here this lock icon is unlocked. For the margin type, we have two different options. The first is the radial option and the second is the along surface option. In the case for the radial option, the 2 millimeters are defined straight outward in perpendicular direction to the optical axis. When we change the setting or this margin type here to along surface and we click on update, the 2 millimeters are defined along the surface tangent, so in angled direction. And those aperture margin settings are important for the optimization of edge thicknesses. So during the optimization, the edge thickness is always calculated based on the real aperture, including the margin required for our lens mountings. For manufacturing reasons, it is often desirable that both surfaces of a lens have the same aperture size, and that can be achieved by checking or activating here this link aperture checkbox. So let's activate it and click on update, and now we can see that here our first aperture has increased in size and has now the same size as our second aperture of the second surface here. So in that case, QUADOA computes the radius of the floating apertures for both surfaces and then takes the larger radius of the surface 2 and resizes the smaller aperture radius of surface 1 so that both apertures are equal in size. The next setting applies to multi-configuration models as shown here. If the floating aperture radius depends on the configuration, we can observe the behavior that by clicking through our different configuration states, the floating aperture changes its size. We can also show all configs together, and there we can see that we have, for different configs, we have different aperture sizes. However, of course, in a real system, there's only one lens and the aperture does not change in its size when switching the configuration states, for example, in a zoom system. And in such cases, the floating aperture must have the maximum aperture size across all configuration states. And to achieve this, we can click here on our lens, then we click here on this plus icon, and here we have this link configs checkbox. And when we activate this link config checkbox and we click on update, we can see that now the lens doesn't have different aperture sizes, but only one aperture size. So once this is enabled, clicking through different configuration states will keep the aperture at a constant size because it is set to the size that accommodates all configuration states. And of course, you can combine all those lens settings, so you can combine the aperture margin, the margin type, the link aperture checkbox, and the link configs checkbox. You can combine them all together if necessary. Thanks for watching.